Hey guys, how's everything going? Let's take a look at number 40, combination sum 2. Actually, we just finished 39 combination sum. So this is just like a slightly different version of the problem. We're still given a collection of candidates numbers and target, find all unique combinations, blah blah blah. But this is different. In previous problem, the any number could be used in any times, but in this problem, we can only use the number in the candidate for once. But this comes at a cost that the numbers are not unique. It means that the candidates are not unique. Yeah, you can see that there's double one in these problem in these candidates. And actually, we can do the same as what we did in the last problems. So if you haven't seen that video, if you want to know more about the details, please refer to my last video about 39 combination sum. I think it's pretty straight. It's pretty easy to understand, and it has a good explanation there. I'll try to add a link on the screen. You can also click on that. Okay, so I just I just copy paste the code. Okay, this is actually for combination sum 1. The first thing the first thing is that we need to sort. This doesn't change, and the changes are, it says each number in the candidates may only used once. In the previous example, when we try to add new numbers to the existing tempo array, we start at the index, right? We give an index, we start with the index. So actually, the next time the next I, we should pass it to I plus 1. It means when we have put 1 in a number, we should put the next one in the number. So this avoids the duplicate. But the other problem becomes that there's another problem that, like, if they are all ones, for this one, it will traverse all the possibilities of all ones, right? So for this one, it doesn't need to check. For all cases that are possible, for all cases that the ones above this one, after this one, are already checked at when we are at the round of this one. So we have to avoid this also. If that this one plus 1 1, and then we check here, we still got 1 1, so that's not cool, right? So we need to avoid wait a minute, avoid duplicate results by checking if they are the same numbers in a they are consequential same numbers duplicates. So if here, if num equals the previous one, then we should ignore it. But the problem is that when we are checking like sum to 3, we check this one and this one and this one. Actually, these 3 could be one possible solution. But if we just do this, it will skip this one because the one here equals to the previous one. So we need to keep the first number valid and just skip the other numbers. So the first index is okay. So if I is bigger than index, we only skip for these ones. Yeah, so which means that we check the first one and then go to next one and go to next one. We find 3, right? So we go to this one. No, it's already 3, so we just skip this one and go to next number. Move this one forward, but it's the 1. It's the same, so we just skip all the way ones. Skip all the ones. Yeah, just please draw some cases on your on the paper, and you will understand that better. This is actually is a common cases. I think I've made that in threesome. I think in another problem that's similar to this, and I've done the same. So keep the first one and skip the consequential same numbers. Keep the sequential duplicates. I'm not sure whether I express it in the right English, but you know what I mean. Okay, so yeah, let's run the code. Accept it. So let's submit. Yay, accepted. And the time and the space complexity doesn't change too much from the previous problem, so I just leave it there. And that's all for this problem. Thanks for watching. See you next time. Bye bye.